Let's have an example. F of x equals to 9x plus 2 all over 3x plus 12. Set the denominator 3x plus 12 equal to 0. Then transpose positive 12. So it will become negative 12. Then divided both sides by 3. 3x divided by 3 is equals to x. And then negative 12 divided by 3 is negative 4. So that our vertical asymptote is negative 4.
The horizontal asymptote. If the degree of h of x is greater than to g of x, the horizontal asymptote is always or 0 or x-axis. For example, f of x is equal to x plus 2 all over x squared minus 42. As you can see, the degree of denominator is greater than to numerator. The asymptote is 0 or x-axis.
Our example is f of x is equal to 7x plus 2 over 21x minus 3. Since the degree of g of x is equal to h of x, the horizontal asymptote is the quotient of the leading coefficient of the numerator and denominator. Copy the leading coefficient of numerator and denominator. Then simplify. The horizontal asymptote is 1 over 3.
Oblique asymptotes will only occur if the degree of numerator is greater than to the degree of denominator. For example, f of x is equals to x squared plus 2x plus 1 all over x minus 3. So in this example, there is an oblique asymptote. To find oblique asymptote, we will use long division. X squared divided by x is equals to x. X times x is equals to x squared. And x times negative 3 is equals to negative 3x. Then subtract. X squared minus x squared is equals to 0. And 2x minus negative 3x is equals to 5x. Then bring down 1. 5x divided by x is equals to positive 5. Then 5 times x is equals to 5x. Then 5 times negative 3 is equals to negative 15. Then subtract. 5x minus 5x is equals to 0. And 1 minus negative 15 is equals to 16. So our oblique asymptote is x plus 5. X plus 5.
First example, f of x is equals to x plus 16x all over x squared plus 3x plus 2. First, let's find vertical asymptotes. Like what we explained earlier, we need to set the denominator is equals to 0. To find that, we will use trial and error. We factor this expression into this. We should think a number that when we multiply it to itself, the product should be the constant of the expression. And when we add that number itself, the sum should be equal to the coefficient of the second term. The factor of 3 and 2 are 2 and 1. Why? Because when we multiply 2 and 1, the answer is the constant 2. And when we add 2 and 1, the answer is 3. So that the factor of x squared plus 3x plus 2 are x plus 2 times x plus 1. After you find the factor of this expression, equate the factors to 0. So, x plus 2 equals 0, you need to transpose 2 to the right side. So, x equals negative 2. Same thing to the other factor, you need to transpose 1 to the right side. So, the answer is x is equals to negative 1. At the vertical asymptotes, let's move to horizontal asymptotes. If the degree of numerator is less than the denominator, the horizontal asymptote is always 0 or x-axis.
Let's try this example. F of x equals 2x squared plus 4x minus 12 over x squared minus 10x plus 25. Notice that the degree of numerator is equal to the degree of the denominator. Is to find the horizontal asymptote in this rational function, get the leading coefficient of numerator and denominator. So we have 2 over 1. Then simplify so that our horizontal asymptote is 2. Next, let's find the vertical asymptote. In this case, our denominator is x squared minus 10x plus 25. So, first we need to do is to factor the expression. To find the factor, we will use trial and error. We need to think a number that when we multiply to itself, the result will be the constant of the expression. And when we add that number to itself, the result should be equal to the coefficient of the second term. That number is negative 5 and negative 5. So we have x minus 5 times x minus 5 equals 0. Then set the two factors equals to 0. So x minus 5 equals to 0 and x minus 5 equals to 0. Transpose negative 5 to the other side, it will become 5. So that the vertical asymptote are 5 and 5. Last example is f of x is equals to x squared plus 4x minus 21 all over x plus 2. First, let's find vertical asymptote. To find vertical asymptote, set the denominator x plus 2 equals to 0. Then transpose positive 2 so that it will become x is equals to negative 2. Therefore, our vertical asymptote is negative 2. How about our horizontal asymptote? Notice that the degree of numerator is greater than the degree of denominator. It means that there is no horizontal asymptote, but we do have an oblique asymptote. How can we find oblique asymptote? To find oblique asymptote, we will use long division. So, x squared divided by x is equals to x, then x times x equals to x squared, then x times 2 equals to positive 2x, then subtract. X squared minus x squared is equals to 0 or cancel, then 4x minus 2x is equals to 2x, bring down negative 21. So 2x divided by x equals to positive 2, then 2 times x equals to 2x, then 2 times 2 equals to positive 4, then subtract. 2x minus 2x is equals to 0 or cancel, then negative 21 minus positive 4 equals to negative 25. Our oblique asymptote is x plus 2.
First, we have no horizontal asymptote. Okay, we have a vertical asymptote of x equals to 1. We have to graph. We graph x equals to 1. This is x equals to 1. And next, we have to analyze the y equals to x plus 2. We have to y intercept 2. Y is intercept to 2. This is x plus 2. Y. This is x plus 2. Next. This x is substitute by 0. X 0 2 plus 0 plus 1 equals 0 minus 1. 0 plus 0 plus 1, 0 minus 1 equals to negative 1. We have to point this in. We have to point negative 1. We have point there. Negative 1. And we have to graph. Next, substitute x by 2. Okay. 2 plus 1 plus 2 minus 1. 2 4 plus 2 4 plus 2 plus 1 equals 7. 2 minus 1 equals 1. Is equal to 7. We have to point 7. And we graph. And that's it.
Isang dalagang Pilipina ay